Now we're going to look at some examples using this definition of absolute value. And here they are. So the first example says, or for all of these, it says rewrite each without the absolute value bars. And it doesn't mean just come and erase the absolute value bars. By no means. You have a condition needing to be met. Okay? So let's take a look. In the first example, if x is greater than 3, take a value, 5. 5 minus 3 is 2. Its absolute value is 2. All right? 7. 7 satisfies that. 7 minus 3 is 4. The absolute value of 4 is 4. So what is happening? Any value meeting this condition of being greater than 3 will assure me that when put in here, in this cluster here, that what's inside of the absolute value bars will always be positive. What happens when you're taking the absolute value of a positive? Nothing. So in this instance, okay, what we have is, okay, to rewrite this without the absolute value bars is to simply say x minus 3 provided x is greater than 3. And that was the condition there. Okay, let's look at this example. Rewrite x minus 4 for x less than 4. 0 is a number less than 4. If 0 is a number less than 4, when put in here, 0 minus 4 is negative. The absolute value of a negative is positive. So we put in a 0, we ended up with a negative 4, then we took its opposite. Okay? Any other value in this meeting this condition will also ask you to give, will result in you getting the opposite of what you had. Okay? So to remove the absolute value bars here would be at the expense of making this the opposite, x minus 4, the opposite, which is, if you prefer, the opposite of x plus 4. So for any value within this range of values, any value less than 4, again, just pick a value, see what happens when you throw it in. When you throw it in, the overall items inside of here go negative. The absolute value takes their opposite, and therefore, in general, with this set of values, the cost to this expression is to take the opposite. Okay? Now we come down here, which is kind of like a combination. Rewrite this, okay, for the numbers, for the set of numbers simply in between 3 and 4. That's the interval, okay? Remember, it could be expressed as 3 to 4, okay? So if that's the case, all right, let's see what happens. Pick a number between 3 and 4, 3.5. 3.5 minus 3 is 0.5, positive. What happens to positive in terms of the absolute value? Nothing. So therefore, in this grouping, there's no effect, okay? It simply stays as x minus 3, all right? What about over here? 3.5 goes in. 3.5 minus 4 is negative 0.5. What does an absolute value do to a negative? Gives you an opposite. Any number within this range of values, when plugged into this absolute value expression, results in a negative, okay, inside of the absolute values. The effect of the absolute values is to take the opposite of that. So here we go. Then the effect there is to take the opposite of x minus 4, okay, and now we simplify that. We got x minus 3 minus x plus 4, and this simply, as you can see, the x drops out, okay, and we have simply 1. So this whole thing, interestingly enough, okay, when you take and assign it values between 3 and 4, will simplify to 1. So that's how we're using the properties of absolute value to rewrite this expression for the condition stated, okay, and simplify it. And we could take it'd be interesting because we can actually take a look at that from the graph. All right, so let's let's pick up the graph of that and actually show you a few things, if you will. Okay, so let's go on here. Let's get the graph going. So let's come back. Let's graph. And we're going to build on the absolute value. So we got the absolute value, and I'm just going to say, oh, what do I want? I want to graph this overall thing. Yeah, the absolute value of x minus 3, close parentheses there, plus, again, the absolute comes from the catalog, so it's the very first thing in the catalog, plus the absolute of x minus 4. So let's throw that in. And okay, that should do it. Now let's just we don't need these anymore, so I can just turn them off or get rid of them. Okay, so I can just clear them, and I can clear that. Okay, now, all right, now let's see. We'll take a look at this graph, and then we might resize the window to convince you that this is exactly what it's supposed to be doing. Okay, all right. So let's take a look at this back here again. I want to make sure x minus 3. See, there's the problem. I did up here. Yep, I thought so. Okay, I put in, and see, it's very easy to make that mistake. I put in here instead of the I put the opposite key instead of subtraction. So let's correct that. Okay, so here we go, and that should do it now. And let's take a look at that graph. Okay, so here's the graph, and it looks to go flat. Looks to go flat. It's not that V shape that we saw in a regular absolute value bar. Well, let's show you a little feature. I'm gonna box in just this region to illustrate that. Now, where is this? This is between 3 and 4. Actually, let's not do a box. Let's just show you something else. Okay, go to diamond F2 and resize the window. Okay, we're going to resize the window to be on X between -5 and upwards to +5. Okay, and then on Y, let's go the bottom number, -2. That'll just be a way of getting a closer look at this. Okay, so here we go, the graph, and here it is. Okay, all right. Now, I probably should have opened that a little bit further up. Let me go revise that a little bit for you. So let's go out to the X max of, let's say 8. Okay, there we go. Here we go, graph. Okay, here it is. All right, what do we got? Look, between the X values of 3 and 4, the Y value here is 1. It's flattened out, defending the fact that, what did we punch in here? We punched in this expression, and graphically we're illustrating that that expression between the numbers of 3 and 4 is definitely 1. And there you have it.